Hi, and thanks for joining our webinar. So I can see that quite a few of you already joined, so perhaps we should just kickstart this. So so thanks for joining our TL methods webinar series, where we're going to focus on developing different test methods and talking about different test methods of decontamination technologies, air disinfection technologies, and similar. So just to go through some of the basic stuff. So yes, please use the Q&A tab to ask questions. We'll try and answer them at the end of the presentation. Yeah, the webinar slides and the webinar recording will be shared with you in the next couple of days, so you'll be able to watch this when time is right. And then please join in the conversation using the hashtag TL method and follow Test Labs page to see all the latest updates, and we'll be sharing more even to follow up for the webinar as well. So what's coming up? So what we're going to talk this afternoon is we'll touch on UVC technologies and efficacy claims. We'll talk about the variations in some of the results that we see in the literature. We'll talk about the challenges behind comparing UVC light sources and why is this a challenge. We'll discuss about the test methods for UVC light testing that we've developed with the team, and it has to be a repeatable test method. And then we'll touch on microbial efficacy and validation. So I'll be chairing this webinar this afternoon, but I'm joined by my colleagues. So Enrico, he's our lead microbiologist here at Test Labs. Mohammed, he's our research scientist and technical writer, and Kurt Morgan, and he's our embedded systems engineer. So just to start the conversation, guys, when it comes to UVC technology implementation, what do you think is the driving force behind this? Are these marketing claims or scientific evidence? Let's start with you, Mohammed.
I think it's marketing claims because they can persuade the clients or customers with their misleading information. So I think they drive what's going on, basically, the marketing field.
What do you think, Kurt?
It depends. If a company wants a long-term relationship with their customers, they've just got to deliver on efficacy and quality. It's got to be science. But if a company wants to sell things now and they don't want their relationship, then I suppose it's hype all the way. So I kind of feel for customers who are trying to discern the difference. I mean, all it's gold, but at the same time, there are lots of good products out there.
No, that's sure. What do you think, Enrico?
Well, I guess it all depends, because I've seen a lot of claims out there. I mean, some of them they're definitely science-based. It depends how the science was performed and how everything else was kind of surrounding that. So that's my kind of take. I don't think they're all just marketing. At the end of the day, we'll also, but yeah, it has to, I want to understand a bit more about their science. So I guess that's why we're doing this today.
Yeah, no, I think it's really important to, to ask that, because clearly the market is moving. We've seen an increase in the use of UVC technologies, since 2020, and clearly that was a response to the pandemic. And it's absolutely evident in the amount of research, papers being published on a monthly basis. And it's absolutely clear there's several technologies being used and utilized in different ways. But I suppose the challenge is that, when you do talk to, to customers, you feel that they are quite confused. And when you try and compare different technologies, specifically for different applications, there isn't really a method. So when we talk to customers, I guess there's three things we're often hearing is that, okay, well, when it comes, I suppose what's important for them is how long does it take? So time, how far away, so the distance, and then what the log reduction, so the efficacy. And it seems to me that all these three things are actually kind of describing one. And then when you try and compare different products or different technologies, it's kind of difficult because I think certain products would see different, applications, etc. So although there's plenty of literature published, I think most of the information is lost in marketing claims, and there's a lot of wild marketing claims. But I suppose trying to make sense of it, what's lacking, I believe, is a kind of a justified test method that you can repeat and then make sense of it. And so based on that, I think it brings the question of where is the literature focused on? Like all the research that we see being published on a monthly basis, where's the focus? What do you think, Mohammed?
So during my research, I found that less studies been actually done on the application of different UV light system in different rooms, and more efforts being focused on the efficacy of UV light technologies in decontaminating personal protective equipment and reducing microbial and viral counts in the environment. And I've noticed that more studies being done like within the laboratory and under experimental conditions rather than real life based scenarios. So during my literature research, I found significant and huge differences in the findings being reported, and more specifically, as I mentioned, regarding the efficacy and the most effective dose or light intensity. And this has evidently increased since the start of COVID-19 pandemic. And the efficacy is usually expressed in log reduction, which is an algorithmic value that represents a certain percentage which describe the efficiency at killing or inactivating certain microorganisms. For example, log 1 reduction means 90% reduction, and log 2 means 99 reduction, and log 3 means 99.9, etc. And log 6 is the golden standard for disinfection, so anything from log 6 and above, in my opinion, is a winner.
Okay.
So during these studies, I found using the same light source, intensity, and microorganisms, they reported like significantly different findings. And most of these studies didn't report all the aspects of their methodologies, and also didn't specify the measurements of the cycle parameters, such as the humidity and the temperature, the distance from the light, the exposure time, the distance,
Okay. Well,
presence
that's very
of soiling, and and the room structure, and so many others. And also the type of surfaces play important roles. And I've noticed that has been neglected in the literature, because as we know, surfaces have different properties, and UV light may actually react differently with different surfaces and may actually cause degradation of these surfaces. And some surfaces can have nooks and crannies or microscopic holes where they can basically provide protection for the microorganism to hide and evade the disinfection cycle. And as we know, UV light relies on the direct exposure of light on these surfaces, and in that case, these microorganisms will just hide from the exposure. And I think all these parameters are vital to measure and report the right level of efficacy, and all these conditions must be reported to have a validated process that can be repeated in different environmental conditions.
I think it's interesting, and I guess where I was trying to gauge is that, you know, if your aim is to try and work out the efficacy of specific light source or specific technology, or if your aim is to try and, you know, test the application of specific technology, you'll be setting different criteria and perhaps different test methods. And it seems from what you were saying that the focus is more efficacy. So if the focus is the efficacy, so do you have enough evidence to move on and say, yeah, the light is effective, this is the effective dose, we should go on and focus more on the application and just see how we can implement.
Exactly, because they haven't even investigated the effect of measuring the same wavelength but using different distances, different exposure times, in different rooms with different like shadows, etc. All these parameters haven't been investigated in that depth.
Okay, and I guess as far as the test methods go, is there like a unified test method or anything that we can learn from the literature to try and repeat based on what you found?
These test the test methodologies, as I mentioned, they didn't really specify everything, because like some studies they reported significantly different values for the same microorganism, and this has been evidently seen with SARS-CoV-2. And there's a numerous amount of research being done on UV light and SARS-CoV-2. Like for example, this study was published around August last year and reported a log 6 reduction on SARS when exposed to a UVC dose of 1,048 millijoule per cubic centimeter, and the light source was placed at a distance of 3 centimeters above the bottom of the wells or the plates that contain the viral stocks. So whereas in another study, recently published study, which was published around November last year, they found that a dose of only more than 100 millijoule per cubic centimeter was enough to cause log 5 reduction, and keeping in mind that the light source was placed 30 centimeters above the viral stocks. So this is where the confusion can happen, because when I look at these two values, I wouldn't be able to determine which one is the best solution for a certain application. Because first of all, the first study required 10 times more than the second study. And also the distance was 10 times more than the second study. So they put in the first study, they put it within 3 centimeters, which was really in close proximity. And therefore, they shouldn't be they shouldn't have lower dose, they should have higher dose. And that was the case. So therefore, we can't really conclude if this is applicable in a healthcare setting or real life scenario, because it was done in a laboratory under very controlled conditions. And as I said, the parameters haven't been reported. And however, on the bright side, coronavirus in general are known to be very susceptible to UV light and is considered one of the least microorganisms to develop any sort of resistant mechanism against UV light. So on this slide, some argue that UVC at 254 nanometers has higher germicidal activity because it has longer penetration distance than, for example, 224 nanometers, which is the wavelength for far UVC. So therefore, using different wavelengths may actually give different findings. So, for example, one study evaluating the efficacy of far UVC device found that a dose of 4.5 millijoule per cubic centimeter caused 90% reduction, which is log 1 reduction in methicillin-resistant Staphylococcus aureus. Whereas for conventional UVC lamps using the common low-pressure mercury lamps, the dose required for log 1 reduction was 3.2 millijoule per cubic centimeters. But however, both technologies were evidently effective. So how do these values compare? Is it because of the parameters, the dose, the technology itself, all these combined together? So all these questions must be answered to provide an ultimate solution rather than just giving out numbers in different dosages, causing more confusions in the research field. And this is why we were inspired to develop our own test method that will enable us basically to answer these questions and all these challenges.
Yeah, so certainly, so I can definitely see, well, Carl, I guess you jump in. So there's definitely a challenge. Like we're looking at different, wavelengths of different UVC, sources, etc. Different doses being reported, and there's certainly some confusion even within the scientific community, which isn't helping when you see confusion with marketing claims as well. But as far as developing a reliable, repeatable test method, what is the main challenge you think, given our experience so far? And why it's important to develop, a test method that's reliable and repeatable?
Oh, I'm not sure there's only one challenge. O'Mahony and Co. in 2020, they developed a set of core principles for UV light investigations. So they were suggesting that these 5 ideas, we need to look at some safety, knowing the UV spectrum of interest in the experiment, using calibrated equipment, and ensuring the samples were kind of uniformly illuminated, and knowing about the stability of your UV source over time. So I suppose for a range of representative light sources and organisms, I really want to work out a formula that links light exposure to efficacy for different exposure times, because I want to be able to scale that data using my formula to design systems that could give us the required efficacy levels on particular organisms in a specified time. We could also use that formula to work out some kind of value for money score for light sources or for whole systems. The problems in getting that are, what is this exposure? And is it the same every time I turn on the light? If this exposure has to do with sort of the light spectrum, that kind of invisible colors of the UVC light, and the intensity of the light, how do I measure that in a calibrated way? Can I reliably repeat exposures? I mean, do the bulbs age? Do they warm up and emit more or less light of different spectrums over time? How do I line everything up so it's all repeatable? We've got light sources and biological samples. They've got to point them in the right directions. And then we've got directional light sources like LEDs, which complicate things again. I quite like the way we're handling our LEDs. We've put them on a cylinder in an attempt to make them geometrically similar to all of the other cylindrical light sources we're using, which is quite clever. The light sources are also kind of dangerous. I mean, the UV light is potentially carcinogenic, but it can also cause photokeratitis, which is like a sunburn of the eye, which sounds horrible. Some of the light sources have high voltages, they're hot, we've got to manage all that stuff. We've also got to do ever so many experiments. We don't just want one set of data, we want loads of data from lots of different distances, lots of different light intensities, lots of different organisms. Goodness me, we've got to capture a lot of data and do these processes quickly to have something useful. It's also, how do we practically size these things to fit them on a table? What process lengths and times do we use when we're starting up to get any kind of efficacy that we can measure? But I suppose the main point is that everything depends on the kind of changing characteristics of particular light sources over time. you can't talk about dose without talking about the spectrum of the light source and the intensity change over time.
So I suppose what is obvious to me that you've just raised quite a few questions, and I'm sure our listeners probably have even more questions. I suppose I'm trying to get to a point where what are the answers, and there's two things that resonated with me. So first of all, well, anything that anything you test, you need to have a scalability factor. So the results should be scalable, and we need to test that. And then you say it should be tested under the same conditions that you can go and repeat and do a lot of that to have some statistical power and draw a comparison. But based on what Mohanad was saying, and I think where I find it most interesting that different wavelengths reporting different doses, etc. What's that, and what is this wavelength, and why it's important to know that?
Firstly, I mean, dose doesn't mean anything without referring to a specific light source. You've got to be comparing apples with apples. You can't compare a study 254 nanometers, 222 nanometers, and look at the two dose numbers and compare them. It doesn't work. Shorter wavelengths of light, they have higher energy in each photon of light. So the same dose, the total energy from two different light sources, could give you totally different numbers of photons with very different energies in each photon. So the higher the energy you've got in one photon of light, the stronger the bonds that it could break. In terms of chemistry, that's what happens when a UV light hits a cell. It can do chemistry, it can break chemical bonds. But there is kind of a threshold for these things. If you've already reached the point where your photons have enough energy to break chemical bonds, having more energy isn't going to do anything if you've already killed things. But you are kind of wasting power. So if I've got, I suppose, we'll look at an example of it in a second, but there's also the possibility that you might have filtering effects from biological structures. I mean, you've got sort of dead skin cells, you've got cell membranes. There could be stuff going on there with the different wavelengths of light. But I think one of the other bits in terms of Mohanad's observation is that, speaking as an engineer, measuring UV sources and the calibration of UV measuring equipment isn't trivial. It's really difficult stuff that could go wrong. I'm also aware that the light sources, they change a lot as they warm up. It's obvious if you look at them, just from the visible component of the fluorescent light sources that I'm quite familiar with. You can tell if they're brand new. You can tell if they're starting from cold, and you can tell if they've been running for a while just by looking at them. So if anyone's been using sort of single point in time measurements to work out what the intensity is that they're getting this dose from, and then scaling it by amount of time that they've had the light on for, they might not be getting the right answers. I suppose the other bit is I'm not sure that dose is really the right thing to be talking about at all. To use a really silly example, I think this is probably a logical fallacy, so someone will probably call me up on this, but if you think about me using a truly huge dose and applying it to a sample over a really, really long amount of time, the intensity of light would be really low, to the point that it wouldn't bother, or certainly wouldn't kill many organisms, and in fact they might breed quite happily. But if I was to take that really, really big dose and apply it almost immediately in a few microseconds, I could vaporize the sample. So same dose, different effect. Using this kind of silly example, maybe it's not the same stuff. In a more kind of probably practical way, if DNA damage is what's causing the UVC to be kind of effective in killing things, maybe you can ask a microbiologist about that. Maybe you need a lot of damage to some DNA in order to kill it. If there's a cumulative effect, that would give you what we might see a kind of close relationship between efficacy and dose. A bit like when you measure air pressure. If the individual molecules inside a balloon don't make an awful lot of difference, you don't notice the air pressure gauge wobbling because of them. But maybe if we had really low doses of UVC, or it only took a few individual photons hitting some DNA to prevent the organism reproducing, there might actually be quite a spread in efficacies in different results, just statistically, because it's about probabilities. But I don't know. I don't actually know which of those scenarios we're dealing with. I'd love to find out, though.
Yeah, well, so I suppose we're at the point now. So, we started off with doing a literature review. We really wanted to find out exactly what's being done in the scientific community, try and learn, most from them, from what's being done, and see whether we can just repeat that. Well, we found out that's actually not that as straightforward as it seems. So, we did say, no, we actually have to develop our own method. Well, we looked at all the kind of safety precautions, anything that we need to do to make sure that we do it right, if you like, to do with light measurements. So, yeah, so what is the method then? Kurt, just go and talk us through. So what we've actually...
Yeah.
There you go.
Well, we're going to set up some light sources on a table, which you can see there. We're going to put biological samples at various distances, like 20 centimeters, 40 centimeters, 80 centimeters. I think the listeners can figure that one out, around the light source. And we're going to expose our biological samples to different process times, starting from cold each time, and see what happens in terms of efficacy. We're going to measure the efficacy of the lamp on these biological samples. We're going to make sure that we kind of share this whole experiment with people. We're going to give everyone the exact procedure that we followed, and the exact plans for making this rig, so it's repeatable. Both for us, so we do the same thing twice in terms of having everything clamped down, but also in terms of it being easy for other people to perform the same experiment in the same way if they want to compare their light sources or organisms. We're going to use glass slides to house the biological samples. We picked using glass because glass is smooth, so there aren't those nooks and crannies. It's non-absorbent, so we can dry out samples of biological organisms on it. And it's easily available in standard sizes, so people can actually make up this experiment in different universities. We're not going to be making any assumptions about efficacy and intensity and dose. We're going to link what we can control, which is for a given bulb, given organisms, a given distance, to what we can actually measure, the efficacy. We're mindful that the light sources might change over their lifetime and during the processes. So we're going to start each test with a room temperature bulb, which is what happens in the real world. Normally a piece of equipment is wheeled from one place to another, room temperature. And we'll be measuring the light intensity in the spectrum of the bulbs when we buy them, after 100 hours of running and after 200 hours of running, so that we can tell if our results that we get are actually representative of what happens when you run a real system with real bulbs over any length of time. Then we're going to look at the spread of the efficacy results and see if efficacy can be related to what you might call dose for a particular light source over a useful range of doses and process times and light intensities, because dose would actually be, if it dose could be related to efficacy in a straightforward way, that'd be really easy to use as a number to scale things, to design systems. Our light source distances, light intensity being inversely proportional to distance squared for a point light source, and hopefully for our column light sources, if we're lucky. We're actually going to get several different combinations of process time and intensity to give the same dose. So if there is a relationship between dose and efficacy, and not everything else, then we'll see it. And that'd be really interesting bit of this sort of test. I think that's been the most interesting bit from my point of view.
As far as the UVC light technologies that we're hoping to test, just correct me if I'm wrong, there's 4 sources that we're going to go for. Can you just give me quick examples of what is?
So we're going to use these 220 nanometer eczema bulbs. Very exciting thing. And there's all this talk about the safety case for them may be because of the really high wavelengths that they're using, that those photons might have such high energy that they don't even penetrate the dead skin layer, and then they might be safe because our 254 nanometer fluorescent tubes, one of the other ones that we frequently use here at test labs, they can actually cause eye and skin problems because it's quite high energy light source, but it can actually go into your eye through the cornea. So it's interesting to see the difference there. We've got pulse xenon sources. I know that there are some systems that use them. They emit a fantastic amount of power. They flash though, So that it could be interesting trying to use our calibration equipment to measure the.
And they do go quite broad, don't they? They go UVC, UVB, UVA.
Really broad spectrum.
Yeah.
I mean, this is your thing. If Mahana was pointing out, if I talked about the dose of light coming from that pulse xenon thing, I think the lights we're using are 1500 watts. I mean, they are bright lights, but that won't all be in the UVC spectrum. So in terms of the millijoules per centimeter squared, it'll be an enormous number for whatever efficacy we get. But we might not actually quote that. We might think a little bit about when we talk about doses over what spectral range we're interested in. And there's the LEDs. The LEDs are about 265 nanometers, so slightly longer wavelength than our fluorescent bulbs that we're used to. Maybe even what I have seen is people talking about the this sort of magical place where the UVC light is most effective. Some people talk about 254 nanometers as if it were an effective wavelength. It's just the wavelength that happens to be emitted by mercury fluorescent tubes.
Exactly.
So it's not a brilliant wavelength. By happenstance, having a 254 nanometer wavelength photon, it's got enough energy to break lots of the bonds that you get in biological systems, carbon and nitrogen and whatnot, and break bonds from DNA. So that's useful. The 265 nanometers, I'm not sure if it's quite powerful enough to actually do so many chemical bonds. So it'll be interesting to see if it's as effective at.
Definitely. So when you look at the spread, like we have anything starting from 222, so the excimer bulbs have 254, 265, and then obviously the pulse ones, so they will cover quite. So I think essentially what we're saying that there's going to be a lot of data for specific wavelengths to see how they compare. So I look forward to seeing the results. I think most importantly for me will be then to say, okay, well, as soon as we're going to try and find a scalable way for the efficacy, well, then what is the application? Because I think each of those technologies most certainly have their role, but it's just whether the application, what is the best application for each of those?
Yeah, I think that's a fair point.
So it seems like you have a good stand there. Yeah, the final bit is the efficacy. And Enrico, we have you here. Like, so it seems like you got the easy end of the stick, but is that true? What is the challenge between selecting an efficacy assessment or method for that?
Yeah, so you see all of you what I have to put up with, lots of engineers, lots of minds. Nobody knows what a bacteria is actually. I guess the biggest challenge, something I will actually link to what Mo said at the early stage of this webinar. It's majority of methods are laboratory control. Let's not kid ourselves. Our method will also be laboratory control, which, as good as we can be and as close as we can try to be, will never be the real thing. Obviously, the challenge itself, as Kurt just described, will start off at least using these glass slides. And the slide is a perfect representation for what we're trying to do. You won't necessarily be decontaminated slides in a hospital or glass necessarily. You'll be decontaminated all sort of surfaces. So I guess to me the biggest challenge will be able to provide the correct dose or the correct challenge each time, every time we're going to start moving, because we're going to start moving forward. So my idea would be to start, obviously we'll start with this glass slides. So the first attempt to kind of have a proof concept whether or not our method is working, our method is giving us some sort of good results. We'll start off with producing bacterial culture on suspension, obviously dry them off on these glass slides, and then also they'll be exposed to the various UVC system, as Kurt described, various distances, various time. I mean, we're going to start small. My idea is it's always easy to add on once you establish your method, rather than starting off trying to do everything in one go and then make a mess out of it. So my idea would be to starting with 3 representative sort of organism. We'll be starting with E. coli, Staph aureus, and Candida, so representing gram-positive, negative, and a fungi. And then from there, we will move on. So the idea would be, I know everybody talks about this amazing log 6 reduction, which everything is striving to achieve and get to. Let's be clear, luckily we work under standard, so we do actually a lot of disinfectant work. So we are quite used to how the disinfectant kind of works and what is required. A lot of the requirement actually is log 5, because we all know the log 6, it's really difficult sometimes to achieve. And perhaps you don't even need to have log 6 in certain situation. although the more the better, obviously. So I guess we're going to obviously start trying to get to a log 6 reduction if we can aim for that. And in case fall back to a log 5, which by a lot of standards actually is the most acceptable method. So you will get a thumbs up from a lot of authorities. A lot of hospitals will be happy if you can say we definitely killed, log 5 of any kind of organism, if we can try to prove that. And then what I'm interested in personally is be able to take this method further, i.e., can we replicate this on actual surfaces? Can we then include all those little things that we discussed so far? So the Mo said, are we considering the surface? Are we considering microscopic holes? Are we considering whether or not everything is compatible? So, and I guess this is going to be kind of ever-evolving method where we're going to start small, validate it, make sure it works, and then from there on, adding more and more and more to make sure our results are also comparable to the real world. Because as I said, I don't want to be, at the end of the day, produce yet another paper where we're all proud of it, but at the end of the day, all we're putting out there is the same literature that Mo was actually, was already read and say is actually not very good. So I don't want to be part of that. We want to, and that's why I think we're trying to involve so many people, so different experience, different knowledge, especially. So each one of us can contribute and make sure that we can put out the best methodology, and which will be then reproducible in other labs, so other people will be able to obviously do it. And again, the results, something that we can actually trust. And that's what we're hoping for. I'm not going to say we're definitely going to be able to do it. It's science, so I always come from my point of view of biologicals. They behave in different ways, but that's what we're hoping to get to. And as Taji said, I'm really excited as well. I can't wait to start. And yeah.
Yeah, and I guess that's why we started, this webinar talking about, the feedback we're getting from from healthcare and in their confusions, and I can only level with them. So look, it is confusing, like even for us, and we're trying to answer those questions. And then listening to all of you guys, I know we had this idea that how amazing would it be to have all the technologies tested, and then you get your log reduction per minute per pound spent kind of thing. So this matrix of, yeah, well, right, if you want this log reduction in this amount of time, perhaps LEDs isn't your thing. Maybe you should just stick with low pressure mercury, just to try and level the playing field, to say that there's certain the right technology, there's certain amount of efficacy that they all can achieve, but then there's an application piece alongside all of the other, surfaces and all the other challenges. But I look forward to kind of being able to, to have this matrix and say, what do you want to achieve? And, all the facts are there. And hopefully this will, help the marketing claims to be so much closer to what the real life is, rather than, pretending that UVC light source would, will follow you around the surface and, will catch you and ultimately kill you. So as a summary, I guess, from all of you guys, you all represent, a big part of this development of this test method. And, I'm just so glad that we work as a team. So, Mahana, you from the literature review, Kurt, you from the product process development, looking into different light sources, and Enrico from Efficacy. Before we jump into the questions, and please, guys, submit your questions through the Q&A tab. Just a summary and then we'll go into the question section.
So yeah, variations in the findings and huge gaps in the literature, I found, even though there are numerous amounts of research in UV light, and the research findings and marketing claims keep causing confusion with inconsistency in findings, and many studies reported different efficacy results for the same pathogen, which could be, as we mentioned, as a result of different parameters or conditions during the test process that aren't specified or examined. So this is the summary from the literature review.
From my perspective, I suppose it's think about the spectrum of the UV light you're talking about. You can't talk about dose without talking about the spectrum of the UV light you're talking about. And think about how the UV light varies over time. Cold or hot, old or new. It actually affects the light sources.
Thanks, Kurt. And Enrico, just summarize.
I guess for me, the most important thing, that's what I really want to find out. It's just give some clarity on the claims that we make, that everybody makes, and just share some light that some things are not actually true, and because there is a reason why. And again, I've seen all sort of claims from people saying I will kill 100% cells, which if you talk to anybody who understands the minimal biology, that's the biggest lie that's ever been said. But that's not just so to me, it just gives some clarity and say, yes, a log 5 is actually achievable if you meet this condition with this UV lamp, and therefore then you'll be able to understand, well, that's a good system for my need. rather than just say this system is good for everything. Let's just, which I think, again, we all should, that's why it's more like educating and make people understand that you can't just buy something just because it looks fancy. There has to be some sort of, you know, real research done before and some quality data that support all those statements.
Okay. So just jumping into the questions, I think if we can just summarize one thing, I just make sure that we know what I really want the listeners to leave with understanding is that when it comes to specific light sources and their wavelengths, and why is wavelengths important? So these, you know, breaking of these bonds, Kurt and Enrico, I guess Enrico, you can talk about the DNA, but Kurt, just absolute clarity about what is the wavelength, why it carries more energy per photon, and what does it mean for?
Well, I mean, I'm an engineer. I claim to know all the physics developed before 1920. Maybe I don't actually know. That's slight arrogance coming in there on my part. But I've heard of something called the Planck-Einstein relation. So I know that the energy that there is in the photon is equal to a constant times the frequency of the light, or the energy is equal to a constant times the velocity of light divided by the wavelength, to put it the other way around. So that means that when light is emitted, you can think of it as being like bullets from a gun. It comes out in lumps. And when you have really high frequency light, you have more energy in those bullets. And that's it. But when you talk about a dose, that's actually an amount of power. Sorry, pardon me, I'm getting my own terms wrong here. A dose is an amount of energy, possibly even an amount of energy spread over maybe a centimetre squared of something exposed. So if you were to have photons of different wavelengths, in order to get the same dose, you'd need less photons of a shorter wavelength or more photons of a longer wavelength, because they've got less energy per photon. But at the same time, if photons have already got enough energy to break bonds and stop pathogens, organisms reproducing, be efficacious in some sense, maybe you don't need more power, you probably need more photons. I would be personally thinking that rather than talking about a dose in terms of energy per centimetre squared, it might be more useful to talk about a dose in terms of photons per centimetre squared with enough energy to be effective.
Well, that's really interesting. And this is where I think, Enrico, I want to discuss it with you, and one of the questions as well, that we often refer to this effective dose, and there's plenty of we can go and test your light source to see that you achieved the log 4 efficacy or log 1 efficacy. And then I suppose what essentially the person responsible for technology implementation is faced with is just this report saying, yeah, this technology, wherever the light source, whether that's on casters or fixed to the ceiling, whatever, achieved this efficacy. And that's a singular number. And I suppose what is missing from that dose number, which is we may be log 4 reduction in 5 minutes. Is that enough, or what else would you expect to see next to that dose? I suppose this is enough.
Yeah, no, I mean, again, unless that dose is pre-programmed on your machine where you can just hit one button which says whatever 250 millijoules per centimeter, it makes no sense, especially for the end user where most likely they never, they have no idea how this system works. So I guess, yes, I guess at the moment, I'm trying to protect some of these claims, perhaps try to defend them from a microbiological point of view. Some of these people are trying to claim that for those, you mean sort of the irradiance, so how much light intensity is being generated over a certain amount of time. The irradiance itself will be calculated also from, again, how much light is being generated over distance. So if you then take these three kind of parameters into account, then you could come up with this so-called dose, i.e., for Staph aureus, you might need, 4.5 millijoule per square centimeter. So I think that's what they're trying to refer, but I don't think that's the best approach, and I don't think that's what we should be kind of trying to achieve. I think overall, these claims should be coming, rather than with a dose, should be coming with parameters and say, your UV system should be placed at X distance for X amount of time with this X amount of lamps, for example, which would generate an X amount of power. Obviously, the system will be already built in. So then perhaps what you're going to do as an end user is place it at the right distance for a certain amount of time. And therefore, once all these, all these data, they've been kind of validated, that you can always then repeat and achieve the same dose. In terms of, yeah, go for it.
No, I suppose just to pick on that. So there's two challenges there. So if you're designing a UVC system and you're trying to rely on literature to support your claims, well, we've just learned from Mohammed it's difficult to do so because which one do you pick? So you're most likely to pick the lowest one because that's the easiest to deliver, in those ways. I'm not saying, but it could be the case. Second of all, if you do attempt to go and test things, then you miss out all the key information saying that yes, I somehow achieved my efficacy of block 4 within 3 centimeters of my challenge. Let's just say that is obviously possible. But then if your application is trying to decontaminate something that's 5 meters away, well, that clearly isn't going to work. So I suppose when we talk about these parameters, we need to be absolutely clear that I think that those reports should actually include the actual application. Otherwise, it's just, unless there's a way of, assuring that. So that's clearly the case.
I think whenever you think about UVC light systems, it's all well and good to talk about a dose, but if you've got a UVC light system in a room, there are going to be some surfaces in the shadows where there will be no dose. There might be organisms in the cracks where I've got no idea what dose they're going to get. The surfaces are going to just be distributed, everything from absolutely facing the light sources. This is like the winter and the summer business. On the North Pole, that you get a kind of grazing angle from the light coming by, and it's very cold. Whereas at the equator, the light hits you full in the face, and the land is warm. The same thing is applying to UVC systems. So I don't think that you can just put a number into your system to say dose and press the go button. You need to. Well, I think when people are buying these UVC systems, they need to be thinking about the sorts of environment they're going to be using them in. And I'd really like to see salespeople coming along with a model of their room, almost with sort of fake colors being used to show which bit of the room is getting what kind of dose for a particular setup, or even a picture where you have the system that's being installed and where it shows in colors what efficacy you get in different bits of the room, including with the various surfaces. Maybe even give you the options of where you could position the system for best use. Because just saying log 6, this thing on wheels, it means nothing. And it gives you the thing is that UV light fits in with a whole load of other things. If you don't clean the room, the soiling of any sort is going to stop UVC light from being effective.
That's another huge topic. Yeah, that's another topic. We can do a webinar about that as well. So
no, the other bit is that you've got a UVC light system. And if you're buying it, you're comparing it to other technologies. I mean, should you spend getting more time manual cleaning? Should it be a UVC system? Should you use maybe hydrogen peroxide, which is going to be more effective if longer?
Yeah.
You're picking stuff, so you've got to have information to choose.
Yeah, and this was exactly my point at the start of this. Like, what is driving the market, or the decision making? And sadly, my own opinion, at the moment, it seems like more marketing claims are being made, and sadly, that not necessarily relates to what happens in real life. There's one specific question about safety, which actually, I honestly think that maybe we should actually consider as part of this test to try and work out, what would be the. I suppose the question is whether whether glass is safe to attenuate UVC light or stop UVC light. And I think generally speaking, without knowing the thickness of the glass, it'd be difficult to say, but it's easy to test. So I suppose for the listener that asked the question, I think, well, maybe we should include in this test protocol, which we haven't, so it's a good time to do that. We can still add things. Let's just check, what would be the thickness of glass? Because clearly, when you look at practical implementations, you use it in a healthcare hospital, you have windows or the partitions of glass, and would it be safe for you to deploy it? And what would be the scalable factor, not this for this specific light source, for all these light sources? And so I guess the question is that it's easy to test. Under normal circumstances, glass would obviously stop UVC light, but then it depends on thickness and other variables. Plus, there's different wavelengths as well that we need to understand. But Kurt, do you want to comment on that? Just briefly?
That's really interesting. Actually, in terms of we do this sort of experiment quite often because that's a question people ask, and the window that you're sitting in front of there definitely attenuates all of the UVC light sources that we've used so far because we've tested it, because we don't want to get that photokeratitis ourselves. But interestingly, although we don't get UVC light from the sun because it gets stopped by the atmosphere, we do get UVA and UVB light from the sun. So many plastics actually have stuff in them specifically designed to get rid of UVC light, to attenuate it. And it's difficult to get plastics which are pure enough to let light go through to use it in test equipment. So if you want a little window that lets UVC light through so that you can measure it, it's difficult. And it also, the plastics then get degraded and they kind of wear out over time. So I don't think it's something you have to worry about too much. If there's a UVC light system being used and there are normal windows, that's probably okay.
Okay, and so I think that's about what we have time for. So thanks all for joining. We will do more of these TL method series of webinars talking about different test methods for other technologies as well. So thanks for joining, and we'll look forward to seeing you in the next one, which is going to be on the 29th, I think, of next month. So we'll do one, and we'll see you in the next one. Thanks for joining. Thanks guys for being part of this. Enjoy this. So
cheers.
goodbye.
Thank you very much. Bye bye.
Yes, everybody. Bye.
Right.